This time we're verifying trig identities. So this is the problem type 1 in your homework this week. So we have to prove secant x plus 1 times secant x minus 1. And we want to show that is equal to tangent squared x. So whenever you are proving something, start from the left-hand side, work, and make that look exactly the same as what's sitting on the right side. So don't work with tangent squared x. That's going to be where we want to get to, okay? So I'm going to start on the left-hand side, and let's see what we can do about this. So let's go ahead and FOIL this out, you guys, okay? So if you do secant x times secant x, you get secant squared x. Now multiply secant x times negative 1. That's negative 1 secant x. And then these two middle terms, well, they're going to give me plus 1 secant x. Those two will cancel out, right? Those two orange terms will cancel out. Lastly, if I do positive 1 times negative 1, I will get negative 1. Now, the middle terms will cancel out, leaving us with just what? Okay, so there's these two. Negative and positive secant x, they're gone. So I'm only left with secant squared x minus 1. Now, what did we just do to go from the first line to this line? We used just algebra. So we use algebra and another algebra. We simplified to get it down here. But now we're going to need some trig identity, okay? Now look what we have here. We have secant squared x minus 1. Remember this, okay? Secant squared x minus 1. I'm going to go back up to the table that has all of our Pythagorean identities, okay? Now, I'm going to do something to the middle line right here, okay? What will happen if I move this, adding 1 to the other side? We'll be able to rewrite this middle equation into this, okay? We're going to get tangent squared x is equal to what? Secant squared x minus 1, right? So simply by rewriting that second line of the trig identity, the Pythagorean identity, I'm going to copy this and I'll bring it down here. We just made up something that we need, okay? Look, what do we have here? We have the same exact secant squared x minus 1. So what does this turn into? Tangent squared x. And now what did we just use in this step? Well, I didn't use algebra there. We used the Pythagorean identity. And once you get the term that you have on the right-hand side of the equation, then we're done. Okay, so we just proved it. So we use algebra. We use algebra to first simplify the expression, and then the last step, we use the Pythagorean identity. We use the Pythagorean identity to get it down to tangent squared x. So that was one example, part A. Now let's look at another one, okay? Let's look at another one. We'll put this one over here, okay? So this time we have, what's a mess, okay? We have sine x plus cosine x squared. So what we're going to do is start with this side, work it out, simplify it as far as you can, and see if you can make it into this form, okay? That's what we're going to do for proving. So just ignore the right-hand side. Just write out that second side, the left side. So what I have is sine x plus cosine x squared. I am about to FOIL that out. So I'm going to write it out twice. Let us FOIL this, okay? So first times first, sine times sine is sine squared x. Now, when you do sine x times cosine x and another sine x times cosine x, we're going to get 2 sine x cosine x. We're going to get 2 of those, right? Now, the last terms, cosine times cosine. What's that going to be? Cosine times cosine is cosine squared x. Now, guys, I want to point at these two things here for you, okay? What is sine x squared plus cosine x squared? Okay, what is sine x squared plus cosine x squared? Okay, I'm going to zoom out and show you the first line of the Pythagorean theorem. Sine squared x plus cosine squared x is equal to 1. Okay, so look, these two yellow highlighted terms, they add up to 1, right? So this and this, they add up to 1. So what I'm going to do is I'm going to put 1 right there. And I'm just going to bring that green plus 2 sine x cosine x down. Now, hold on. I thought I saw something just like that on the right-hand side, didn't we? So look, compare this. Is this the same as what they have on the right-hand side? Oh, yes, it is. So we proved it. So what tools did we use here? Well, first, we used the algebra, right? We FOILed it out. But we definitely used, like, that Pythagorean identity. When we combine those two yellow highlighted terms into one, okay? So both examples that we went over in this video, we use definitely algebra to FOIL it or to multiply it out. And then Pythagorean identity came in handful to simplify the expression. But that's it for this topic number 3.